Welcome to Research Creations, and thank you for clicking on this video. In this video, I will be covering the topic of energy changes, which includes exothermic and endothermic reactions. I will be using reaction profiles and examples to explain each of the reaction categories. I hope you'd enjoy this video and learn a thing or two about energy changes. To understand what energy changes are, we would need to know the following. Energy is absorbed to break bonds. Energy is released when bonds are formed. To put it simply, bond breaking is endothermic, and bond making is exothermic. Remember this, as it is very important in the following sections. We can show energy changes in energy diagrams and reaction profiles. Endothermic reactions are reactions that release energy, most commonly through heat or light. As stated in the previous section, heat is released when bonds are formed. This means that exothermic reactions usually replace weak bonds with stronger ones. Exothermic reactions can happen spontaneously, and because they release energy, they feel warm to our senses. Let us visualize an exothermic reaction with an energy diagram. As you can see here, energy is being released from the reactants by the reaction. Thus, the product will have less energy. The downwards arrow visualizes the energy that is given out. A better way to represent energy changes in a chemical reaction is a reaction profile, because it includes the activation energy and starts at the energy of the reactants. Here, you can see the activation energy as the double arrow and the change in energy as the downwards arrow. One example of an exothermic reaction is combustion. Combustion is just a fancy term for burning. When you want to burn, for example, a piece of charcoal, you light it up with some fire, which is the activation energy, and then it lights and gives off heat. This works with all fuels, such as petrol and natural gas. Endothermic reactions are reactions that absorb energy from their surroundings. As stated in a previous section, heat is absorbed when bonds are broken. This means endothermic reactions usually break bonds instead of creating new ones. Endothermic reactions can only happen when there is heat present, and because they absorb energy, they feel cold to our senses. To visualize an endothermic reaction, I will start off by showing an energy diagram, then a reaction profile. As you can see in this diagram, the reactants have less energy at first, but the reaction absorbs energy. Thus, the product has more energy than the reactant. Now moving on to the reaction profile, the double arrow is the activation energy, and the upwards arrow represents the change in energy. Here, you can see that the change in energy is the difference between the reactant and product energies. One example of an endothermic reaction is evaporation. Evaporation is the change of state from a liquid to a solid, and it requires heat energy to occur. For example, when you apply water to your skin, it quickly evaporates by utilizing the heat from your skin and the surrounding, thus making that area of your skin feel cold. And this is the end of the video. Thank you for watching until the end. Like the video if you enjoyed it, dislike it if you didn't. Sharing or subscribing to my channel would be much appreciated. Thank you for watching Research Creations.